All right, so now we're going to move on to section B in this chapter about indices, and we're now going to focus on just rational indices. So remember, we know that indices is the same thing as our power from our last section. So we know that when we talk about indices, we're talking about something raised to a power. And we know from our first chapter what a rational number is. So a rational number we know is expressed as a fraction, p over q, where p is an integer, and q is also an integer. So we know what rational numbers are, and we know what indices are. So what this section is going to be about is anytime that we have a rational power. So something like x raised to the 1/2 power. This is what we're going to be focused on now, where our power is a fraction. All right, and remember, we're always going to be focusing on questions. I realized the last section we didn't really focus on any of these questions, but we're always going to be focused on our essential questions throughout the entire unit. And our essential questions for this one now are: how are indices and radicals similar? And why should we have multiple ways of writing or reading mathematical statements? All right, so this is what I want you guys to be focusing on throughout this unit, throughout this video. This is something that you should always be using to help generate some questions or to help with what it is that we're trying to learn. All right, now before we get into solving any problems, I kind of want to focus on this question a little bit. How are our indices and radicals similar? So we're going to talk about this example here, right? X to the 1/2 power. So when we have our x to the 1/2 power, sometimes we need to rewrite. It's easier when we rewrite our rational indices as a radical. And we need to know how this translates as a radical. So one of the ways I want you to always think about is this 1/2. You can say it in words as power over index. So this 1 represents our power, while this 2 represents our index. So when we go to rewrite this as a radical, x is our base. It's what's being raised to the power. So that is our base in our radical as well. It's what we're taking the square root or the nth root of. And then our power is what it's being raised to. So we can say x raised to the first power. And our index is what root we're taking. So that's the number that we will put here. So remember, when it's a 2, we don't have to put it there because it's always understood when nothing's written that it's a 2. But we can for now just to show you where it goes. So our index is what root we're taking, and our power is our power that we're raising our base to. So this is how we can rewrite our rational indices as a radical. And something that is important for you to be able to do because it helps with simplifying some of the problems, and it makes them a little bit easier down the road, right? So just remember, one more time. So if we have x to the 1/3 power, what this is saying is it's our power over our index. So if we want to rewrite this as a radical, we first draw a radical sign, we rewrite our base inside our radical, and then we can raise it to the power like we did here, or we can re-raise the entire radical as the power. Either way, it's the exact same thing. And then our index is what we write inside of our radical. So this is telling us we're taking the third root, or the cubed root of this number. All right. So that then leads us to one of the very first things that we need to talk about, and it's called the nth root of A. All right. So the nth root of A. And what this is saying is anytime you have a number, A, we were using x here, and it's raised to the 1 over n power. So our numerator of our rational indices is a 1, and then the denominator is whatever number it is, n. This is equivalent to taking the nth root of that number. Right? So these are equivalent to each other. And it's just something that you need to be able to know. And then there's going to be problems that we're going to go over where this is not a 1 and it's a different number. And we'll talk about how we'll go about solving that. All right, so now we're just going to go through a few examples pretty quickly. And if you notice, they're all raised to the 1 over n power. So 1 over n power. So what this is telling us is that we're just taking that root of those powers. So this first one, it's 1 over 2. So that's telling us that we're taking the square root of 49. And the square root of 49 we know is 7. And remember, another way that we can remember this 1 over 2. It's our power over our index. Well, this 49 is being raised to a power of 1, and anything raised to 1 is itself. And then here we're saying we're taking the square root. So the square root of 49 is 7. Here it's 1 over 3. So if we do our our nth root of a, then we would just know that this, because it's 1 over 3, so we know that we're taking a cubed root of 27, and a cubed root of 27 is equal to 3. Right, now for these two over here, it's very similar to what we're doing, but now each of them are raised to a negative power. So remember, the first thing that we have to do is we need to rewrite it so we have a positive power. So it's 1 over 49 to the 1/2 power and 1 over 27 to the 1/3 power. Because now by moving them from our numerator to our denominator, it's now going to make them a positive exponent. So then we need to go ahead, it's our nth root again, because it's 1 over 2, so it becomes 1 over the square root of 49. And as we know, the square root of 49 is 7, so this then becomes 1 over 7. This one then becomes 1 over the cubed root of 27, and as we know, the cubed root of 27 is 3, so it becomes 1 over 3. All right, so anytime you have a power that's 1 over any number, n, it's just saying we're taking that root of our power. So we can rewrite it as a radical because it's a little bit easier for us to visualize what's going on, and then we can go ahead and solve. All right, so now I want to go over an example where our power does not have a numerator of 1 for our rational index. So if we put it here, we would then have 4 raised to the 2/3 power. Or I'm sorry, 4 raised to the 3/2 power. So 4 raised to the 3/2 power. Remember, I was telling you to remember this as power over index. So now that our power is something other than 1, when we go to rewrite this as a radical, we can rewrite it, as I showed you before, 2 different ways. We can first write our radical, and it's now 4 being raised to the 3rd power, and our index is 2 because it's power over index, so we can put our index here. Or we can rewrite it as the square root of 4, and then we can re-raise this entire thing to the power of 3. So we can rewrite it where just our base is being raised to the power, or the entire radical is being raised to the power. And this shows you, though, what this is showing is that we can figure out or solve for this or simplify this number 2 different ways. This here, the first thing that we would have to do based on our order of operations is we would need to go ahead and do 4 raised to the 3rd power first. So then we would have the square root, and 4 raised to the 3rd power is 64. So the square root of 64 is equal to 8. So writing it this way is telling us that we want to do the power first. Writing it this way, since here we have the parentheses, we need to do our parentheses first. So we would do the square root of 4 first, and that is 2. And then we're left with 2 cubed, or 8. So see, no matter which way you do it first, whether you do the square root or the nth root first, or we raise the power first, we still get the same answer. All right, so what this is showing you is that sometimes when you're solving these, it'll be easier to take the root first and then raise the power at the end, or sometimes it's easier to take the power first and then take the root at the end. It's really your own preference and your own call. For this one, I would say it's probably easier to take the square root first because then we're working with a smaller number as we're raising it to a power. All right, so now let's just go through a couple examples. All right, and as I was showing you in that last slide here, we have a to the m over nth power. We can either take the nth root of a first and then raise it to the power of m, or we can take raise the a to the power of m first and then take the nth root. All right, so now we're going to evaluate these without using a calculator. So we have a to the 4/3 power. So remember, it's power over index. So we can rewrite these. And now since we're trying to raise 8 to the power 4, I think it's going to be a lot easier for us to first take that cubed root of 8 and then raise that to the power 4 at the end. Because raising 8 to the power 4 could be a very large number that you may not know how to do without using a calculator. So here, the cubed root of 8 is equal to 2. And then now we're left with 2 to the 4th power, and 2 to the 4th power is 16. All right, so remember, rewriting it as a radical, it's power over index. So since it was raised to the 4/3 power, I know that my power was 4, my index was 3. All right, so for this one, the first thing we want to do is we want to rewrite it so that we have a positive power. So it's 32 to the 2/5 power. So then from here, we're going to rewrite this. And the same thing, I think it would be easier to take the 5th root and then square it at the end rather than squaring 32. So it becomes 1 over. So I'm going to put this in parentheses. So it's then going to be the 5th root of 32 because remember it's power over index. So this 2 is our power, the 5 is our index, it's what root we're taking, and then we're going to square it. Well, the 5th root of 32 is 2, so this is then equal to 1 over 2 squared, which then we know is going to be 4, so it's equal to 1/4. Right? So that's evaluating without using a calculator. That is it for this section, and it's it for this video as well.